This diagram illustrates the July 2026 update to Brazil's CNPJ identifier. The Receita Federal is moving away from a strictly numeric format. The first 12 positions will accept alphanumeric characters, while the final 2 remain numeric. For most engineering teams, the immediate reaction is to treat this as a standard UI validation and database maintenance task. This split-screen view shows the expected fix. Developers will update the database column from a numeric integer type to a 14-character string on the left, and simply patch the regex input validation. But executing this targeted code fix in isolation is guaranteed to cause cascading system failures. The CNPJ is no longer a superficial data entry field. Over years of development, it has become a load-bearing structural component, embedded deep within your enterprise architecture. You will find it routing logic inside CRM profiles, supplier onboarding flows, billing systems, internal APIs, massive data warehouses, and decades-old legacy code. This creates what we call the regex fallacy. Updating the database schema at the entry point does absolutely nothing to protect downstream systems that still expect to receive a pure string of numbers. Your central tax platform might be perfectly updated and ready to accept letters, but a legacy batch process running overnight might still be operating on outdated numeric assumptions. We are going to examine exactly why deploying code updates before conducting a cross-system discovery of CNPJ usage will silently break business operations. The July 2026 mandate represents an architectural mapping crisis that requires immediate attention from IT leadership. To understand why the quick fix breaks down, we have to look at an architectural concept called semantic drift. This is the process where a data attribute loses its original, narrow meaning and takes on critical structural roles across a business. Over years of system integration, that single data point is pulled into the CRM, acting as a matching key. Here, its function mutates. The CRM doesn't use the CNPJ for tax compliance. It uses it to identify corporate accounts and link parent companies to their subsidiaries. The drift continues into procurement workflows, where the system relies on the CNPJ as a routing attribute to direct approvals or connect purchase orders to specific legal entities. Finally, it moves into business intelligence and billing platforms. In these disconnected datasets, the CNPJ serves as the primary reconciliation hash to ensure records line up. Because the identifier mutated at each stop, now simultaneously owned by finance, sales, and operations and compliance teams, each of these departments only has visibility into their specific silo. No single team maintains documentation of the complete dependency chain. When the alphanumeric format arrives, these siloed teams will not naturally communicate their distinct, localized validation rules to one another. Because the CNPJ acts as the shared connective tissue of the enterprise, a sudden change in its format threatens to sever the routing and matching logic of the entire business. Let's observe a simulated scenario using this data pipeline visualization. A developer updates the customer portal API to accept the new alphanumeric CNPJ format. The gateway receives the payload and registers a successful ingestion. Because the entry point accepted the data without throwing an error, the organization assumes they are compliant. But the API asynchronously passes the payload down into an enterprise ETL pipeline. Hidden inside is an old data cleansing rule. It is hard-coded to strip all non-digit characters from the CNPJ. The string passes through this logic and emerges as a truncated, corrupted fragment. The ETL process does not crash. It quietly passes the now corrupted string into the central data warehouse. The first casualties are your BI dashboards and reconciliation workflows, which group and join data based on this exact field. With corrupted strings in the warehouse, financial reports will silently drop critical records. From the warehouse, the corrupted payload travels further downstream, routed to third-party integrations via message queues. The message queue successfully transmits the string, but the external vendor's consuming application expects a valid 14-character ID. It rejects the payload, breaking automated payments. The final and most severe trap lies at the very end of the pipeline, inside the legacy mainframe environments that handle overnight batch processing. This image of an operator at an IBM 370 console anchors the reality of these systems. These deeply entrenched older COBOL or RPG programs rely on fixed-width file layouts that mathematically assume numeric boundaries for data processing. When the overnight batch job hits the corrupted alphanumeric string, the type mismatch causes a hard crash, halting core business operations until morning. Updating entry points without mapping the full pipeline guarantees asynchronous failure. It turns a successful API push into a ticking time bomb. A common engineering counterargument is straightforward. Why not just search the codebase repository for the word CNPJ and patch every result? This command line interface shows the initial success of that approach. Running a standard search easily flags the surface-level database columns and API fields. But this creates the search fallacy. In real enterprise environments spanning decades, the exact same data concept appears under dozens of different technical names. This network diagram reveals the hidden aliases. An API might define it as tax identifier, a supplier workflow might use supplier document, and a shared validation library might simply use CPF CNPJ. This archival image of a data processing floor represents the era when many of these systems were built. Legacy file layouts often divorced the name from the function, relying on highly abbreviated Portuguese terms that standard English or acronym searches will always miss. The problem goes deeper. Many CNPJ dependencies are not named fields at all. They are undocumented, hard-coded architectural assumptions. For example, a regex pattern that only accepts digits, or a data mapping interface contract that treats the incoming field strictly as a numeric integer. Basic string matching cannot find architectural assumptions, and it cannot identify how data is cast and transformed in memory during runtime. Attempting manual discovery by reading legacy documentation and old ticketing systems is simply too slow and prone to human error for a hard July 2026 deadline. A keyword search only reveals what you already know to look for. It leaves the most critical, load-bearing dependencies entirely hidden from your impact analysis. Before any development team writes a single line of remediation code, they must construct a reliable map of where the CNPJ actually lives. Teams must execute a rigorous discovery checklist. They must answer exactly where the data is stored, where it is validated, where it is transformed, where it is exchanged, and where it is used as a matching key. Discovery must also include severity triage, separating low-impact display reports from mission-critical payment workflows and tax integrations. Because manual mapping and basic searching fail at this scale, organizations require AI-driven structural analysis. CodeAura's platform specifically solves this problem. It automatically parses legacy routines, extracts underlying business logic, and maps cross-system integration points. CodeAura turns buried, undocumented assumptions into a highly searchable visual knowledge base that both technical and business stakeholders can actually read and review. The alphanumeric update is an enterprise coordination task. It requires total alignment between ERP owners, integration teams, and legacy system managers. The July 2026 CNPJ mandate acts as a forcing function for enterprise-wide discovery. By mapping these systems now, organizations can finally document the hidden dependencies that have operated in the dark for decades.